Welcome everyone to our virtual RAM session. I'm Gerard Ames from the Office of Undergraduate Admission. My pronouns are he, him, his, and I'll be one of your hosts and moderators for tonight's session. I'm joined by Fordham College at Rose Hill, along with a few other students from Fordham College at Rose Hill. And before we start our presentation and answer your questions, I do have a few instructions I would like to share ahead of today's session. After a brief presentation over the next hour or so, we'll be answering your questions in two ways, both by video and by Q&A. To ask a question, select the Q&A icon on the bottom of your screen and type the question, which you can post using your name or post anonymously. We'll select a mix of questions to answer on screen so everyone can hear the answer. We also may answer your question by typing your answers in the Q&A function. If the question may be relevant to the wider audience, our team members will answer it so that the answer posts publicly in the Answered tab. While we hope to address a number of key questions, we may not be able to answer all of them, given the number of questions we receive and the short time we have together tonight. We will share contact information at the conclusion of the event for questions of a more specific or personal nature, or if we're not able to get to your question. You can begin typing your questions right now. And before I turn it over to our colleagues to begin the presentation, I want to share some important updates about Fordham. As a New York-based Jesuit institution, we seek to provide a transformational education experience. Fordham's commitment to empowering the disenfranchised began with the university's founding in 1841, when Catholic immigrants were turned away from many other colleges and universities. As Fordham grew, it has taken more of an active role in diversity and anti-racism work, most recently through Educating for Justice, part in the university's strategic plan. You can learn more about our university-wide efforts and our work towards diversity, equity, inclusion, and belonging on our website. We also invite you to explore the university's demographic information on their website as well, and we hope that you'll join Fordham in building a university for all of us. And with that, I turn it over to my colleague, Dr. Beer from Fordham College at Rose Hill. Dr. Beer.
Thank you very much for that introduction, and welcome everybody. I would like to introduce our panelists today and try to give you sort of an idea of what we're going to cover. We're really interested in your questions and having a conversation, but we do want to try information and perspectives from both students and faculty members that have joined us here. So I'm just going to introduce everybody here. We also have academic advisors that I'm not necessarily going to introduce, but just mention who they are. We have an advising center, and they're going to be monitoring the chat or the Q&A and providing you with answers, written answers. We have Sandra Fowler, Corbett Basler, and Lena Castellano that are joining us from the advising center. So I want to acknowledge them, and I really appreciate their help, and hopefully they will be able to provide any answers to questions that you have that we don't answer. So let me just start with the faculty that are here and have them introduce themselves, their name, title, and role, if they're a faculty member, students, their name, major, a little bit about themselves. And we really hope that all of us can share our Fordham experience and how much it's affected us, and what we hope, if you come and join us, that will, come about for you in terms of your experience as well. So my name is Robert Beer. I'm a professor of chemistry. I'm an associate dean at Fordham College Rose Hill. My role is largely at the college level, in addition to teaching classes, is to work on strategic initiatives and resources involving STEM education and pre-health education. So let me introduce Dr. Banerjee. So why don't you speak a little bit about yourself?
Hi, I'm Dr. Banerjee. I'm from the Department of Chemistry and Biochemistry. I also am the Program Director of Biochemistry. Really excited to share some information about the biochemistry program with all of you. It's a new major that we started last year, and it's been growing pretty well. And looking forward to your questions and talking to you.
Dr. Hecula?
Hi, everyone. My name is Yvonne Hecula, and I am in the Department of Biological Sciences. I've been at Fordham since 2010, and I am involved with a lot of undergraduate research in my laboratory. And one of my students who's currently working in the lab and has received a grant is here as well. So she'll be able to talk a little bit more about the actual experience of doing undergraduate research at Fordham.
Thank you. And Dr. Poole?
Hello, I'm Dr. Poole. I am an advanced lecturer in biological sciences. I teach non-majors and majors courses, human anatomy being one of them. And I am the head of the general science major at Fordham.
Great, thank you. So now just turning to students, Stefania?
Hi, I'm Stefania Bonani. I'm a senior. My major is biological sciences. I've been doing research since my sophomore year on campus. I've been in a few different labs, ranging from genetics to field work to now I'm in Dr. Hecla's lab working with sea turtles. So very exciting things.
Great, thank you. And Azar?
Hi, I'm Azar. I'm a physics major, and I've done a little bit of research with Dr. Alvin about lattice quantum chromodynamics. It sounds more complicated than it actually is.
And finally, Hannah.
Hi, I'm Hannah. I'm a senior at Fordham Rosehill. I'm a chemistry major and a biochem minor, and I also do research in Dr. Banerjee's lab with peptide-based therapeutics and bio-nanotechnology. And so if you have any questions about the goings-on in the chemistry and biochemistry department, I'd be more than happy to answer.
Thank you, Hannah. So what I'll do is I'll spend, a little bit of time now just giving you a real overview of STEM and seeing, and then we can follow up with some questions, seeing sort of what people think about courses, and then we'll move on to academic opportunities. We've already seen that some of the students and the faculty have mentioned their research, for example, and so, those are the kinds of things that we're gonna probably, kind of investigate that go on at Fordham. So I'm going to be sharing my screen for this presentation. If you just give me a second here, here we go. So what I'm going to talk about today are the STEM opportunities, and specifically, we're starting off by just talking about, what is at Fordham? What is STEM at Fordham College at Rosehill specifically? Well, the departments that we have are chemistry and biochemistry. That's a single department. Biological sciences, physics and engineering physics, mathematics, computer science, and natural sciences. There's also some interdisciplinary programs that a lot of students are very interested in, and they're fairly popular. It's in integrative neuroscience, environmental science, and general science. And then in addition, some students do dual majors or degree programs. So for example, one example would be mathematics and computer science, or mathematics and economics. There's also a program in engineering. In other words, you actually go to Fordham for 3 years, get a bachelor's degree at Fordham, and then you get a bachelor's degree in engineering at another institution, for example, Columbia University or Case Western are the two ones we have agreements with. There's an accelerated BS/MS in the biology department or computer science, and there's also a 5-year integrated BS MST, which is a degree that you would use to be a teacher as well. So if you were interested in science and wanted to be a science teacher, that would be one route to go. I just want to talk a little bit about, the first year and what you're kind of looking towards in terms of your next step if you're attending Fordham. Is that one of the things really want people to do, especially if you're interested in Fordham, this would apply as well, as familiarize yourself with, what are the STEM staff? What are the behind the word STEM at Fordham? Both academic and non-academic staff all support students and share their experiences and give students experiences at Fordham. And also, what are the resources? Like, what are the labs like? What kind of equipment we have? That kind of thing. What kind of scholarships are available? The other thing you maybe want to think about is, the academic curriculum. That's sort of obvious. What kind of skills you have that make you ready to attend Fordham and succeed in your first year and beyond. The sort of research that you might have opportunities might have later down the road, and what kind of engagement you have. Are there clubs, things like that? There's a lot of sort of first year skills that people don't talk about. We were talking about academic skills, sort of like, am I ready to take calculus 1, for example? But what other skills do you need? And that's sort of what I'm couching in terms of what's called the first year curriculum. How do I talk to people? How do I, email faculty members or other students? Those kinds of things. And then one of the things we encourage a lot and are working on constantly at Fordham is, building a community. All the people that are here, I've gotten to know them. I see them in the hallway. I see them on Zoom. I'm, giving them money, hopefully to do research and other team building experiences that you might encounter at Fordham. So those are things you want to start to look at, as well as those are objectives to be able to become comfortable with or acclimated to as you both consider Fordham and you're here your first year. The FCRA staff, like the advisors that are here, they're professional academic advisors, and the STEM departments to provide information about what classes to take and what the curriculum is. What do I take first? Chemistry 1, then chemistry 2, or do I take bio 1 or N2 alone? Those kinds of things. What all the majors and minors are that I just talked about, and some folks here that are panelists talked about. What are the research opportunities? What kind of, career opportunities are there, or internships or research experiences that I can have? And then we're also really interested in, creating initiatives to help students, like, ones involving, learning about your field, or other programs and events. Like next week, we're going to have a movie on campus about women in science. So that would be the types of things that we're trying to do here at the college that we hope you join in. These are the resources that students use to learn about and get help with the STEM curriculum and the majors and beyond. Some of the experiences that we're going to be talking about today. The Academic Advising Center, I already mentioned. There's leadership in departments. Those are chairs, associate chairs, professors, and other staff members. The programs I mentioned, they're directors of these programs. There's also tutoring services. There's STEM clubs. You can use your peers as advisors. There's a lot of informal sort of mentoring that goes on at the peer level. And then there's a newsletter, emails, postings, and then all these non-academic units that I might have mentioned a little bit before, which are like the, career center. So if you were to decide to come to Fordham, let's say you're a senior, what can you expect for the summer of 2024? There's a first year survey. You might take a math placement exam, sort of get your academic placement scores in order. You get some guidance. So we're working with you already in the summer once you've accepted here. We also, in the summer, work with you on registration for these classes through the Academic Advising Center, who, kind of have a close attention to and a close reading of what your needs are, and work with you by email largely, or meet with them for registering for lectures, labs, and recitations. Recitations are these discussion sections that students also attend that help you with your homework and just learn the material a little bit better. So The advisors are a great resource to add or drop or make changes in your science curriculum or coursework. Your major you may be thinking about, you may not know exactly what you want to major in. You can be undeclared, you can major in all sorts of different majors that we just went through, and you can change them as you start to think these things through in the summer. Just as it's sort of your starting point, but it doesn't necessarily mean it's your end point. And all the people that would help with that could be some of the STEM associate chairs, your advisor, or a dean, or an academic advisor. And then there's also a resource for pre-health advising if you're interested in, the pre-health professions. But your main point of contact is your academic advisor through the advising center. So I just want to go back and just by closing say, this is me. I'm the associate dean for STEM and pre-health education, and also point out the importance of your first sort of point of contact, which is the academic advising center. There are a lot of non-academic services that you might encounter that will be important either before or as you come to campus, and that includes career services. I already mentioned counseling and psychological services. The Office of Disability Services, if you have accommodations, definitely want to reach out to them as you come on campus or in the summer beforehand. And the STEM clubs, any kind of peers, people that you can contact, and just pay attention to your email in particular. I'm just going to highlight here the advising center. You can just go online, and this explains a little bit about academic advising for FCRH students, and specifically information for incoming first years. That's particularly useful. So I'm going to stop there and start to ask some of our panelists and faculty members to comment a little bit on sort of the academic roadmap. We've sort of introduced STEM to you, but one of our first goals this evening would be to help you explore sort of academic opportunities at FCRH. Fordham can give, students opportunities to start their curriculum in the sciences through their introductory coursework. So I was going to ask each of the faculty that are here to comment a little bit about the introductory coursework in the sciences. Maybe let me just start with Dr. Poole with a question about, what do you think, as a STEM student coming in, what you think would be a good start, depending, or to figure out what your interests are, your major?
So that's a good question. I always tell, back when I was doing first year advising, that the student really has to come in thinking about where they want to be, because 4 years, they go by so fast. Everyone comes in, oh, I have so much time. And then I see them senior year in human anatomy, and they're like, you weren't joking. It's already over. So I think the best thing is kind of sketch out, what your aspirations are, while still taking some of those courses you didn't expect to take. I teach ecology for majors, and that honestly comes up. Well, it's a requirement in biological sciences, and I have a lot of pre-health students say, I don't understand why ecology is a requirement in biology, especially if you're pre-health. To which I always counter, you can't be healthy if you live in a damaged environment. And by the end of the semester, they really see it. Like, why is Lyme disease so prevalent in the Northeast? So I say keep an open mind, and you have to be willing to work, especially that first year, Gen Chem 1 and Intro Bio 1. They're hard, but I would say try not to get wrapped up in the exam nerves, and go at your own pace. And we are always here. The faculty are dedicated, and we never want a student to struggle. So if you feel like you are, that's the time to go ask for help. And we are more than welcoming to students in all of our classes.
Thanks, Dr. Poole. Dr. Banerjee, how can some of the faculty help, or the advisors, how can they help students deciding what to, you know, navigate in the STEM curriculum and some of the academic choices that they're going to make. We have a new major, you know, biochemistry. So, there's all these different majors that people may not be familiar with. They may know what biology is, but not necessarily neuroscience or, biochemistry. What is, how do you find out about that? And what would you recommend a student to do?
Hi, everyone. Basically, what I would like to say is essentially completely agree with what Dr. Poole just said, that you really, first of all, to answer your question also, is like you have to sort of have an idea, or at least sort of make a plan as to what you want to do, what your goals are, and like really stay focused on your goals. Whether it's chemistry or biology, this major actually stemmed from the interest of students over the past 10, 15 years, because it really brings chemistry, biology, physics, as we talk about it, what is happening, I think, especially as we're, learning more from the scientific perspective, it's very interdisciplinary. So talking about neuroscience, so one of the good things about something like a major in biochemistry or neuroscience and things like that is that you are taking courses which blend, so you understand one aspect of a certain disease. I'll just take an example. I mean, as an example, by learning not only about the pathways or everything, but even the chemistry involved, what kind of drugs are designed, how are they designed, and how are those drugs going to work. So there's a course, for example, it's an upper level course. It's bio-nanotechnology in medicine. So you're really learning what is most advanced in the area where students are reading research papers, presenting them, discussing them, and all of that. That's a part, of course, there's the lecture aspect of it. So you're really getting exposed to what's going on currently in the medical field, as well as, how biochemistry essentially is. Like I tell my students on the first day of class, it's basically consider your body as a laboratory, and 24/7 you have reactions ongoing. So how does that work? And it really blends chemistry and biology. So you're taking courses, some courses from biology, for example, molecular biology, and then genetics. And then, of course, the chemistry, learning the chemistry aspect in the biochemistry classes, as well as the advanced chemistry and the, biochemistry classes. The other thing is that you're also going to be able to choose, depending, the way this major was designed. You could choose which track you want. So there's some students who like to learn more of the chemistry aspect. So there's something called the American Chemical Society, which is the largest scientific institution, one of the largest scientific institutions in the world. So that essentially we have a certified program, whether you want to be a chemistry major or biochemistry major. You can do the ACS certification, or you could do the general track, which is more, you have more, if you're more interested in the biological side, you take more courses in that, like physiology, for example, would be something that would count toward that. So it's like we wanted to give students more choices. And then, like one of the professors mentioned here, there's a lot of research opportunities in biochemistry, especially, we're also looking into the like biotechnology aspect. How can we help you with that, and so on. So happy to answer any questions.
Thank you. That's great. Yeah, please continue to use the Q&A to feel free to start asking questions at any time. I was going to address Dr. Hekela and a little bit about biology in particular. I know we're emphasizing that, but we can move to other subjects as well. But that's such a broad, thing. What can you, most of these, science majors have like foundation courses that are quite comprehensive and a survey, and then you sort of narrow things down in a sense to among, what your interests are. But when I say narrow, actually, there's lots of choices to make, right? So maybe you could talk a little bit about what happens, when you take these courses, you get like a smattering of some of the different biology that you could be offered, that you could go into a little bit more detail in your upper division courses. So, Dr. Akela.
Yeah, thank you. First, I want to apologize to everybody. We're having a terrible sort of internet brownout where I live, so that's why the image is not great. But so we have in our department, we sort of have two different tracks in the biological sciences. About half the faculty work primarily in cell and molecular biology, and the other half work in ecology. I'm in the ecology track, and we've just recently created two new integrated upper division undergraduate and graduate courses. One is in animal behavior and one is in conservation biology. And also, like Dr. Poole, I teach the ecology course as well. And what this means is that after your first year or so, although I will say it's never too early to ask about research opportunities in laboratories. So most faculty, at least in biological sciences, are more than happy if they are able to provide research opportunities in their labs so that you can actually explore something like one of our faculty studies macular degeneration using cellular approaches. Another faculty member looks at the microbiome of salamanders and how that helps them fight off chytrid fungus. In my lab, we do a lot of work with historical genomics, looking at how wildlife populations have changed over the last 100 or 200 years to look at how anthropogenic and environmental changes might be affecting environmental health, including the health of wildlife. So there are a lot of different kinds of things going on. We have one of our faculty members studies rats of New York City, and there are a lot of reasons, both involving human health and other things, why that might be important. But so some of these things may seem really esoteric, but they all have their foundations in understanding sort of the building blocks of life, how life changes in response to perturbations, and including things related to human health. So a lot of opportunities. I should mention as well that we have an undergraduate research grant program that allows students to work in laboratories either for credit as classes or for stipends. And so once your mind starts engaging with the sciences and you start thinking, oh, that sounds interesting, that sounds interesting, we do try to do our best to let you actually get some hands-on experience, not just in the classes and labs, but in our actual research labs, seeing if it's something you might want to pursue. And we have a lot of links with other area institutions to also help with networking. There's also a big undergraduate research symposium every year, and it doesn't matter if you're a freshman, sophomore, junior, senior, you can participate in the undergraduate research symposium as well, giving talks or presenting posters. So those are just a few kinds of things that you can do sort of once you become engaged and start thinking about something you might want to test as an idea for yourself in the sciences.
Thank you. That was a great overview from sort of the beginning to the end of, the kinds of things that you can do. I wanted to turn to the students now and just actually, you mentioned something about STEM classes and, seeing that something's interesting to you and then pursuing it. So
Dr. Beer, I just had a question. There's a question in chat asking about chemistry research. Can I just answer it quickly? And
of course, yeah, anything we can answer any of the items on chat.
so the
Just-
question here says, if I did chemistry research at a university already, can I join in my first year? There have been occasions where, students have joined labs in the first year. You can email the faculty member. I mean, if you go to our website, it's chemistry.fordham.edu, and then look at the faculty research. You can, whoever, whichever research interests you, you can email the faculty member when you're here, talk to them, and see if they have any positions open. So yes, as Dr. Hakala mentioned, there is a few students who do get involved in research in the first year, but generally we also encourage, just get your feet wet, just, do well in your classes, once you're, you know, good with that, then, you know, maybe join in the second semester or like in your second year or the summer after the first year. That's when you have all the time. That would be the best thing. I hope I answered your question. Sorry again, Dr. Pierre, to interrupt you.
No, we're absolutely having, this is a discussion, but I love the back and forth. Please, yeah, answer, any of you that are panelists, please don't hesitate to like say, I'd like to add this or that. I think that would make it more engaging. So for the students, and Azar, you could answer this first, is sort of, you know, Dr. Heckler was talking about, you know, finding things that are interesting in your courses and how that might be a jumping off point. So what are some of the STEM classes that you've taken that were interesting so far, maybe surprised you or opened up your mind to, you know, kind of make the next step? And if you did in this path, for any of the students, if especially since, for example, Stefania is a senior, where you kind of like, oh, I tried that, and then you veered off in some other direction. That would be an interesting thing to hear about. So go ahead.
One instance I can think of is the physics labs. So for physics, there's a lot of it is involved math, calculations. You perform an experiment, you measure the results, and then compare it to what you expect. But what a lot of I didn't know coming into college was that the error analysis portion of it, where you can't be sure about your certain results, it's rather extensive. So you really need to hone in on like the mathematical portion and logic behind the errors. And I will not lie, the error was intense. In many experiments, the error of gravity became 10 meters per second when it should never have gone that high. And I asked this to Dr. Aubin, as he was my professor, why did you make it so hard? There was no point to doing all this. And he explained to me how his research focused a lot on the error analysis portion. And that got me interested. If error was so important that even Dr. Aubin, who has a PhD in physics, focused all of his research on it, I should probably focus on it too. And that taught me an important lesson and also got me interested in doing research with him.
Thank you, that's great. So Hannah, any similar experiences where you know, you took a STEM class or you came across a subject that was interesting to you, maybe surprised you or opened your mind? And also, like, did you veer off, like, oh no, this is not good? Did you veer off into something else? You know, like, I think like as I talked about, it's like there's lots of success and there's lots of failure in science, you know, so go ahead, Hannah.
Yeah, so I would say one of the courses that I really enjoyed a lot and definitely was very helpful application-wise was, as Dr. Banerjee mentioned, the bio-nanotechnology and medicine class. I already took that after I started in her research, but it was a really great way to understand how what we were doing like kind of fits in with the rest of that type of research in the industry. You learn a lot of different laboratory techniques, a lot of different tests that you have to do in order to make drugs or other therapies work for, you know, a human body. And it's very interdisciplinary, and so you get a lot of biochem physics. You learn to appreciate a lot of different aspects of all three of those subjects. But the other interesting thing was it was one of the more creative science classes I've ever taken. So a lot of the exam questions or like presentations especially, they focus on like, okay, here's this problem. Like, what are you going to do in order to try to like help that? Like, what studies are you going to do? What techniques are you going to use? What approach are you going to use? And so it really helped me learn how I can be a creative researcher. And that's really what it's all about. And actually, I noticed one of the questions in the chat, like, is there anything that's really close to pharmaceutical science? I would say if you're interested in that, this is definitely a great class to pursue because you learn a lot about drug development or tissue engineering, stuff like that. So if you're interested in stuff like that, when you're an upperclassman, definitely consider taking a course like that.
I would just like to add a little bit about Hannah. She came in very focused. She started research with me sophomore. She told me right away, I'm really interested in therapeutics. I'm interested in the pharmacological aspects, and and she was interested in cancer research. And that's how I guess one of her freshman faculty members, first year faculty members, directed her, like, that's the person you should go and talk to, and that's how she came. And she's already published 2 papers with me, publications in peer-reviewed journals as an undergraduate, and she's actually working on a 3rd one now. So yeah, she's remained focused. That's the main thing I would say for being successful, whether it's undergraduate research, whether it's in your classes. Just as long as you're focused and you put in the work, faculty will go out of their way to like make sure we want to prepare you for the next step. It's not like, what are you going to do for the 4 years, but what are you going to do after you graduate? That is very important to us. So whether you're interested in medical school, whether you're interested in graduate school, industry, whatever field you're interested in within, like, as long as we can help, whether it's us or whether it's the specific, department that you're interested in, we always try to do that.
Thank you, Dr. Banerjee. One of the things you can see is that there's obviously, especially with the students here, they've mentioned their advisor multiple times, and the advisors mentioned they've worked with the students that are here, them multiple times. They're very engaged in doing research with one another. Dr. Banerjee just mentioned like publications, there's talks and presentations that Dr. Hekala talked about, an undergraduate research symposium. So students are very actively involved in the research process, for those of them that are interested. So going back to my question before, Stefania, which was, what are the classes that, since we're focusing at least this first part, we'll move on to the academic opportunities in a little bit, that were interesting to you, surprised you, or maybe opened your mind.
Yeah, so I suppose I have a bit of a different story from Hannah in that I didn't really know what I wanted to focus on within biology when I came into college, although I did know that I was really interested in research. And the summer following my freshman year, I took genetics, which is a class that all bio majors have to take. It's basically the next class and sequence after you take your intro bio classes. And it was a requirement, and I didn't really know too much about genetics going into it, but I realized through that class that I liked it a lot more than I was expecting, and that that genetics seemed to be so fundamental to so many different topics in biology. And so I formed a relationship with the professor over the summer, and then the following semester I joined his lab. That was with Dr. Edward Jabrowski, and he works with fruit flies as a model organism, and he looks at different diseases using fruit flies, different diseases that are genetically related. And so I worked in his lab for 1 year, and I really enjoyed it. But I knew that I wanted to try out something more ecology related rather than just health related, because again, I really wanted to explore. So I joined another lab, a plant ecology lab with Dr. Franks. And now I'm in Dr. Hekela's lab, which is a really cool intersection of both the genetics that I found really interesting and ecology and sort of the environmental side of biology. Because now I'm working with looking at the genetics of sea turtles using their eggshells. We can extract the DNA from those eggshells and then look at different points that are important for conservation. So it's been a really cool journey. And taking that genetics class was kind of something that set it all off. So.
Thank you. That's great. Everybody's got a different path. So you can see, some people come in, they know exactly what they're going to do. So, I'll just tell you anecdotally, when I was a first year student, I wanted to be an astrophysicist, but I'm not now. So, and I'm sure everybody else has lots of different stories where this twists and turns, sometimes. So what I want to turn to is actually, and Stefania actually gave me a great segue into this, is just exploring, once you've taken your courses and you start to get an idea what your interests are, what are the extracurricular things other academic experiences like research that we've been talking about, but also other experiences, any clubs or other programs that you've done. What about the larger scientific community? Have you gone and gone to any conferences or presentations? We even have something I haven't mentioned is the Calder Center. So I might actually ask Dr. Heckela to comment a little bit on that, or Dr. Poole, either one of you. Let's just open it up to the faculty and students to talk a little bit about these academic opportunities that are not necessarily based on classes or going to meet an advisor and starting to do research in their lab, but beyond that, so I'm going to really open it up. I don't know, maybe either one of you, Dr. Poole or Dr. Heckela, could talk a little bit about Calder as an example.
Yeah, Dr. Poole and I have kind of different experiences at Calder.
Perfect.
So I do a lot of work related with field ecology as well. So people trapping small mammals. I work with students who've been doing bird banding, but the Calder Research Center is a piece of property north of the campus it's about 40 minutes north of the Bronx campus. And it is a location where there are research facilities, including there's a small lake, there are trails throughout the woods, there's camera trapping, there's a lodge which has conference facilities, and there are molecular laboratories, and there's also what is called the Vector Ecology Lab, which is a long-standing site for researching pathogens in the environment. But every year, Calder provides, we used to have a site award from the National Science Foundation for the summer research experience for undergraduates program. Right now, that is funded through Calder funds directly. We no longer have the NSF funding, but every year students have an opportunity to work with faculty either at the Calder Center or elsewhere, but there are resources there where they learn about scientific ethics, publication, presentations. It's basically a skill building opportunity. And not to mention, it's like, it's right outside this urban area, and it's like an oasis of green, beautiful trees and paths. And we've had projects looking at sunfish behavior, chipmunks, all different kinds of projects there. But Dr. Poole has actually worked there more extensively on some of the projects related specifically to the Vector Ecology Lab. So I'll let him go ahead and speak about that.
Sure, yeah, I still do maintain a desk up at the Vector Ecology Lab. It's really a regional site. We're part New York State Department of Health and Fordham, so there's a lot of collaboration there from Albany as well as downstate. You can actually look at the Fordham tick index. We're in the off season right now, but that's comes from data that we collect not just at Calder, but each of the counties around New York City, excluding the city. They have their own Department of Health. But yeah, each year we do mosquito trapping, we do tick surveillance. We also look at part of my study. I looked at a number of ticks on mice, for instance, and does infection in a tick play a role in its survival and longevity? And yeah, it's a really cool facility. I've had tons of undergrads work with me. I've also had tons of undergrads go on and work in other labs at Calder. And it really, as Dr. Heckela just said, it's that oasis. You're in the Bronx, most of your undergrad, and it's hustle and bustle. And then you go up there and it's like, oh, here I am next to a stream with a waterfall doing research. And tonight I'm going to be on Arthur Avenue grabbing a slice of pizza or something like that. So it is really a cool facility, and we have tons of molecular space up there. We even have a microbalance that can weigh a single tick, which sounds crazy because they're about the speck of dust. And about that NSF program that we had, and we still do it through Calder funds, but this is something that even some of my colleagues don't know here, is I was an REU Fordham student in 2007. Back before electricity was invented. No, not quite that old, but yeah, 2007, I was an REU student there when I was at school as an undergrad at Trinity College in Hartford, and that really opened the doors, I think, for me, and also maintained connections with Dr. Daniels and Dr. Falco up there. So paths change throughout your career.
Thank you, Dr. Poole. Yeah, so we're talking a little bit about taking what you've learned, your classes, and maybe doing some of your research, and then what you can do to reach out into the broader scientific community. And one of the things just mentioned was this NSFRU program, which is a research experience for undergraduates at different places. And Azara, I think you're applying for some of those, if not mistaken. So I don't know, could you spend a little bit of time talking about NSFREUs and where you're thinking about going and what you might be doing for a minute?
A lot of the ones I've been applying to are mostly experimental physics and physics related. There's a good amount of intersection between like certain projects from certain schools. For one example, the Duke REU, it's primarily focused on like what I do with research in terms of Dr. Alvin, but there's also one at UC Berkeley where they have more quantum computing based, which I also have an interest in. So a lot of the REUs, they ask similar questions, why this REU and why do you want to pursue research? So a lot of them have similar questions, but it's up to you to tailor your interest to what they have available.
Great, thank you. And Hannah, if I'm not mistaken, you've been to some conferences, right? So maybe you could talk about either presenting or what a conference is like, being part of the greater scientific community coming from Fordham.
Yeah, so one of the most favorite things that I've experienced as a research student is being able to not only go to conferences, but also like being able to go to like national conferences over Zoom, be able to present virtually. It's definitely helped me become a more effective scientific communicator. So I've found that it's really important to be able to not only get people at any level of understanding to be able to have a good understanding of what it is you're doing, but also get them to care about what you're doing. I think that there is a certain aspect of storytelling when it comes to research, and being able to like describe that to people has been very interesting, and it's great to be able to see how other people respond to that. It's great to not only have students but other like professors at other universities get interested in what you're doing, be able to discuss next plans, or if they have like a suggestion for what to do or a question of something. It's great to be able to like think about your research from like the perspective of someone else. So I would say it's been not only great for communication skills, but it's also great. It's a great networking experience. It's also great to be able to see what other people are doing and get inspired. And, there's just a lot of cool stuff going out there. So it's great to be able to draw on that and then also contribute to that as well.
I just wanted to add, like, she did win the award at the Eastern College's Science Conference as a sophomore for her presentation in biochemistry. So she's an excellent speaker at conferences. The other thing is like, yeah, you do get to, I mean, for the students, those of you who are considering Fordham, I would like to, you can present at national meetings, regional meetings, travel. And we do have a travel funding too, like a travel grant that can cover at least part, if not full, like the registration costs and all of that. We have for women in STEM, we have, if you're interested in pursuing a career in STEM, we also have the Claire Booth Lewis Scholarship that helps with, some of the tuition as well as for the research that you are working with the faculty on in a particular lab, either in whichever department you're interested in. So there's a lot of other opportunities also, in addition to the fact that as an undergraduate, you're also presenting at these national level conferences. And you know, like she said, making connections. I also saw a lot of questions regarding pharmacology and pharmaceutical sciences in the chat. Again, just to take Hannah as an example, and there's a few other students over the years and many students actually in my lab who came in, like I said, interested in therapeutics, pharmacology. In fact, Hannah has applied to, you know, several graduate schools in pharmacology, cellular and molecular biology, and she was accepted to some of them as well. So it is a very interdisciplinary field. So depending on what kind of research you're doing and the courses that you take, so like at Fordham will prepare you for those kinds of careers as well.
Yeah, and if you have specific questions, we're kind of following the chat a little bit, but we have, you know, so we're trying to keep it relatively general. We will get to, you know, the advisors behind the scenes here will get to some of these questions. So don't hesitate to ask something, you know, specific that you're interested in, and we may be able to address it as well in a conversation. So I just wanted to ask Stefania. Oh, Yvonne, do you have something to add or?
Yeah, I don't want to take time from Stefania, but I did want to mention that one of the things we've really transitioned to in the Department of Biological Sciences in the last 12 years is that pretty much every one of the courses past the intro courses has an active learning research component within the course. And so you are actually conducting some kind of research usually by the end of your second year at the latest. So for instance, in animal behavior, conservation, and in ecology, which Dr. Poole mentioned is a requirement, all of those courses have a component where you're conducting your own research and you're presenting it. So you have an opportunity to really develop the professional development component is that you're actually learning how to convince whatever audience you're speaking to that what you're doing is important. And that's a great skill to leave any program with, but particularly in the sciences, you know, you run into a lot of people who don't have that much experience in the sciences, and being able to talk to a wide range of audiences is important. And so we build that in so that it sets students up if they want to attend any kind of conference independently, that they have the skills. They're not just struggling to develop them on their own. And in terms of students that want to go on to graduate school, we assist with connecting them with potential mentors and how to put together application materials, et cetera. So it's a very hands-on kind of experience. It's not a canned experience, I guess is the way I would say.
Yeah, I think that the point, I think we heavily talked about research. But you know, you can see just like coursework that the research experience that you can get can lead lots of places, you know. In essence, oftentimes people ask about internships. Well, research is in essence aligned with or parallel to an internship experience where you get some real practical experience and you get connected, like I said, to the scientific community in this way, and how to do some real practical things like order chemicals or, you know, do some coding that actually makes of an outcome that's a product, you know. So I was going to ask Stefania about your experience with the scientific community. I know that there aren't a lot of turtles and turtle eggs actually on campus. So like there must be a way to get those, and it doesn't involve being on campus and must involve some kind of collaborative, you know, work. So Stefania.
Yeah, so the grad student that I'm working with, she actually took a trip down to Costa Rica and collected those eggshells. And then she also has multiple collaborators that she's working with. So she's collected you know, we have eggshells from multiple years because we've been able to have that collaboration. I kind of joined the project after most of the eggshells were collected, but you know, that's an example of collaboration. One thing that I wanted to mention is just that there's a lot of like casual groups on campus to you know, collaborate with other students on STEM topics. There's a women in STEM club that is recently formed and super active. They do a lot of pre-health things, but they also have just general like social events and things to get together with other STEM students. I know there's Pause, which is a specifically like pre-vet related club. There's also like the Surgical Society, which they focus on practicing for med school. So there's like a lot of even just casual groups on campus where you can kind of forge relationships and learn a lot of new stuff that way. So
Thank you. Yeah. There are lots. I'm glad you mentioned clubs. Though there are especially a preponderance of free health, clubs. Like pre-vet, pre-dental. There's also some science ones. Azar, maybe you could mention something about the physics clubs. I don't know if you've been involved in those directly, but I know that the physics clubs have had a lot of fun in the past with different things that they've done. So maybe you could comment on that.
Yeah, so I'm a part of the Society of Physics Students, and we picked it up a lot last year in terms of projects and getting more people involved. The highlight of last semester was where a bunch of us stayed over Easter break and we finished building a $3,000 speaker from scratch. It pretty much plays all music from like the lowest of human hearing to the highest of human hearing. And I think I played it a little too much because my hearing may or may not be affected. So, and we also plan on building another smaller scale speaker. Yeah, it is very loud. And we also plan on bringing another smaller scale speaker this semester, as well as finishing building up a little mini muon detector that allows us to detect the muons in like our atmosphere.
Yes, everybody knows about the speaker. The speaker is just, we hopefully will not become a public nuisance to the neighborhood. But the speaker is incredibly loud that you guys build. It's amazing. So that's a really fun thing, and a great way to start to wrap things up, I think. I just want to know if there's anybody that has some other questions. There's one question or comments that was in here about our undergraduate, and we haven't mentioned it very much, but growing in popularity is the computer science program. It is, the career services at Fordham is pretty robust, especially in finding, people internships or research opportunities like we talked about before. And I think that that's, a really rich area that we are very active in. And the major is, like I said, growing. The department's got a PhD program as well as the biology department, so it's quite substantial. So now that we're near the end here, I'm going to hand it over to our host from admissions.
Thank you so much, Dr. Beer, and thank you all for sharing your insights a little bit more to our students. And I want to thank everyone else for joining us virtually this evening. If there are any questions, you may email enroll@fordham.edu or reach out to your admission counselor at fordham.edu/counselor, and I'll put that link in the chat function, and you can filter out to identify who your admission liaison is. While we'll be heading off camera, we'll keep this event open for a few more moments if you would like to copy any of the answers you received this evening throughout the session. And I'll close the event out in about a few minutes. Thank you all to our panelists and our guests, and have a great evening.